avoid Chattermarks and increase the average drawing speed. Learn the maximum speeds and achieve significant higher productivity.
The tube is threaded into the machine, pulled through the tools, and then cold formed. The material must, of course, be lubricated with soap or oil. Then the external tool tapers the tube, and the inner mandrel sets the wall thickness. Between all elements, there can naturally be resonance or vibrations. If there is excessive friction, the drawing process is interrupted briefly. If this happens periodically, you will find Chattermarks on your tubes. This damage can show on the surface, outside or inside of the tube. Then someone has to do something.
When the operator stands next to the machine, the current best practice is to immediately press a panic button to reduce the system's speed and vibration. If the operator is a little further away from the system, either nothing happens, the system continues to operate in this state, or the operator arrives late.
Suppose you could pull the tube at, for example, 80 meters per minute. In that case, the consequence of chatter is that you pull at only 60 or 40 meters per minute, or possibly even slower. In the best case scenario, the operator reacts within a few seconds. In the worst case, not at all.
Okay, let's look at the measuring device that allows us to perform all these magic tricks. Here you can see the Optimizer4D, which analyzes the sensor data in real time, senses these high-frequency vibrations, and detects the tiny pre-chatter signals.
We need about 20 millimeters of space for the sensor near the forming process. That is usually right at the front of the drawing die. We pick a sensor mounting spot where it won't get in the way during maintenance. You only have to mount the sensor once, then you can take measurements easily while continuing production as usual.
That allows you to detect everything that happens where the cold forming of the tube takes place. The sectional view shows very clearly that there is a direct connection from the sensor to the tools. And all forming forces between the inner tool, the outer tool, and the tube can pass through the solid-state structure and be monitored by the sensor. We take the high-speed vibrations and carry out a spectral analysis in real time. From this, we put together a complete process image. Here you can see a typical vibration pattern from a tube drawing process, which ends with Chattermarks. Here at the beginning, you can see the normal tube drawing process, meaning the vibration patterns that occur during typical cold forming. In this example, the machine noise stops at around 100,000 Hertz. Then we discovered something special.
What was not yet known, what we found out, was that in most cases this very dominant signal is typically preceded by smaller signals. The time window is very short. We had observed it for approximately 100 to 300 milliseconds, and that foreshadows Chattermarks.
That means that before the actual chattering, there is a pre-chattering or a faint, small signal that no one has been able to detect yet, but that our sensor technology and data analysis can accurately detect.
Exactly.
And if we have recognized that, then
we found that it was often enough to reduce the machine's current speed by 5 to 10% and then accelerate it back to its normal speed as soon as the event attenuated or disappeared.
That means we only reduce the maximum speed for a very short time until the chatter vibrations have passed, and then we continue at maximum speed again.
Exactly. You can utilize the QASS system to learn how fast you can draw the tubes.
If the process is running smoothly, the system automatically suggests an increase in speed. You can develop a new maximum speed for a tube type, and our measuring device will determine which speed works best.
Exactly. In theory, you could also set a desired drawing speed. You could say, I would like my product to run that fast. And if the algorithm confirms that this will work, the production process will settle at this desired speed. If the process is not stable enough, for example, the production shows frequent chatter events, the speed will stabilize at some point below the desired speed. But in any case, you will learn which speed is optimal for your drawing process.
Until it becomes more turbulent and then we slow down again?
Exactly. Then we either maintain the speed at the current level or even temporarily slow down.
But if you let us, we will find the optimum speed for the tube so that no Chattermarks occur and we can produce at maximum speed.
Exactly.
The increase rates are often significant and we achieve them fully automatically. Here, once again, are the key advantages for the user. Complete avoidance of Chattermarks and, via the automated prevention of Chattermarks, a higher average drawing speed. The system only breaks as much as necessary for a very short time. Then it immediately accelerates again. Based on these insights, there is a gradually increase in drawing speed with each draw, resulting in a significant increase in target speed and productivity. Now that the data is available, you can identify manufacturing issues more clearly and have the chance to increase productivity in other areas as well.